Hello everyone, let's start with the topic binomial series. The word binomial means which involve two terms over here. So in this topic, the main objective is expanding a binomial expansion for a given power, that is a plus b to the power n. So this is our main objective over here, writing the expansion of a plus b to the power n. So for that, first we have to understand and we have to revisit our basics part, that is key a plus b to the power 0, anything to the power 0 is 1. Now a plus b to the power 1. So if you expand a plus b to the power 1, simply that would be 1a plus 1b. Okay. Now next is a plus b square is simple direct algebraic expansion formula is there, a square plus twice ab plus b square. Now a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube, and similarly a plus b to the power 4 is a to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the power 4. Now what I will ask you over here is observe the expansion of this a plus b to the power 4. So if you observe each and every term involved over here, first term, second term, third term, fourth and fifth. Now see, the power is 0, how many terms you have is 1. This is a single term. When the power is 1, how many terms you have? There are 2 terms. When the power is 2, how many terms are there? 3. When the power is 3, how many terms are there? 4. Similarly, when the power is 4, how many terms are there? 5. So similarly, if expansion of this, so in this expansion, how many terms would be there? A plus b to the power n. So number of terms would be n plus 1 extra. Okay. Now observe, this is my in this case fourth term. So power is 4. So let's say this is our first term, second term, third term, fourth and fifth term. There are 5 terms in this expansion. Now observe. So what are your observation? First observe only just the variable part over here. So over here the power of variable a is 4, and what about power of variable b? I can write it down, this is b to the power 0. Now in the second term, observe the power of variable a and b. Then similarly in third, fourth, fifth term, I can write down this as a to the power 0. So what's your observation? So observe. So if you observe, the powers of a are decreasing and simultaneously power of b are increasing. Or you can say this is my first term in the binomial and this is my second term. So the powers of first terms are decreasing. Initially it was 4, then 3, then 2, then 1, then 0. And what is my second term over here? B. So it was started with 0, 1, 2, 3, 4. Okay, now we have observed the variable part. Now let's just observe the coefficient parts involved over here. Before that, I will ask you one more question. What is the power of the variable involved over here? So total power is 4. What is the total power over here? 4. What is the total power over here? 2 plus 2, 4. What is the total power over here? 4. And what is the total power over here? 4. So when n is 4, means when your power is 4, so the power of the variables is 4, means we have distributed power in such a way to both the variables that the sum of that power should be equals to your 4, means in this case it's 4. Similarly in the first scenario, a plus b whole cube, power is 3, 2 plus 1 3, 1 plus 2 3 and 3. Okay, now let's observe just the coefficients parts over here. So now let's observe the coefficient parts over here. So I have just written the coefficient parts from this: 1 1 1, 1 2 1, 1 3 3 1, 1 4 6 4 1. So these are the coefficient parts over here. Okay, done. Is there any pattern you are observing over here? Any kind of pattern? If you see that this extreme sides are 1 1 1 1 1 1. Apart from this, there is one more pattern over here. These numbers 1 2 3 4 are all natural numbers. Now these numbers, these are known as triangular numbers. These are known as tetrahedral numbers. This is a very famous pattern. This is kind of a pyramid or kind of a triangle, you can say. This is a very famous triangle we know. That is, it's a Pascal triangle. And there are so many number patterns involved in this. Okay, so now the question is, on the basis of your observation, can you write down the expansion of a plus b to the power 5? Okay, what first question over here is, when n equals to 5, what would be the coefficient? This would be 1 and this would be 1. Now what about the middle terms? Now if you observe things over here carefully, so what you will see is how you have got this 2 from this 1 and 1, 1 plus 1 2. What about this 3? 1 plus 2 3, 2 plus 1 again 3. Now 1 plus 3 4, 3 plus 3 6, 3 plus 1 4. Similarly over here this would be 1 plus 4, which is 5. Now 4 plus 6, which would be 10. 6 plus 4, which would be 10. 4 plus 1, which is 5. So these are the coefficients in the expansion of a plus b to the power 5. Similarly, if your n is 6, your expansion would be 1, 6, 15, 20, then again 15, 6, 1. Okay, so before this I would share one more pattern over here. All these are, if you observe carefully, are the powers of 11. 11 to the power 0, 1. 11 to the power 1 is 11. 11 to the power 2 is 121. 11 to the power 3 is 1331. 11 to the power 4, 11 to the power 5, and 11 to the power 6. Apart from this, if you observe over here carefully, what is the sum over here? The sum is 1. 1 plus 1, sum is 2. 1 plus 2 plus 1, sum is 4. 1 plus 3, 4. 4 plus 3, 7. 7 plus 1, 8. What is sum over here? 1 plus 4, 5. 5 plus 6, 11. 11 plus 4, 15. 15 plus 1, 16. So similarly, if you observe the pattern over here, so this sum without adding, I would say this would be 32. Every time I am multiplying it by 2, or you can say powers of 2. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. So this would be 2 to the power 6, which is 64. So you can just add this up and verify. Okay. Now on the basis of this observation, how we are going to write down the expansion of a plus b to the power 5. The first concept which we have seen over here, observed over here, that the first term, first variable, the powers will start decreasing, and the second variable, the powers would increase. So using this part, I am just writing it down, the variable part. First would be a5, then a4b, then a3 b square, a square b cube, a b4 b5. So just verify if the powers are 5 in each of the term. 4 plus 1 5, 3 plus 2 5, 2 plus 3 5, 1 plus 4 5 5. Okay, now the coefficients 1, so this is 1, 5, 10, 10, 5, 1. Now just the addition symbol in between. Okay, so now this is one way of doing this. Similarly, I can write it down, the expansion of a plus b to the power 6 using the coefficients over here. So this would be a6 plus 6 a5b plus 15 a4 b square plus 20 a3 b3 plus 15 a square b4 plus 6 a b5 plus b6. So in this way you can write down the expansion for any of the powers. Okay, now the problem is, let's suppose if your powers are 5, 6, 7, 8, or let's suppose 15. So you can just write down this triangle and you can expand the given expansion accordingly. But how to generalize this part? Okay, so to generalize this part, before we need to understand this term over here, that is binomial coefficients. So all these are binomial terms. This is binomial expansion. These are binomial terms. Now, so we need to know binomial coefficients. So all this which we have seen are the part of coefficients. So these are the coefficient. What is coefficient over here? 6. What is coefficient over here? 15. What is coefficient over here? 20. What is coefficient over here? 15. What is coefficient over here? 6. What is coefficient over here? 1. What is coefficient over here? 1. So for that we need to understand this part. So considering the expansion of, this is the simplest expansion we can have, 1 plus x to the power 5. The same logic, in this case we have only one variable. So we know the second variable power starts increasing. So first would be x to the power 0, x to the power 1, x to the power 2, x to the power 3, x to the power 4, x to the power 5. Now the coefficients part, so this coefficient part we have seen in the expansion when n is equals to 5, it's 1, 5, 10, 10, 5, 1. Similarly over here 1, 5, 10, 10, 5, 1. Okay, so now to figure out the coefficient we'll use the concept of combinatorics, which we say combinations over here. Now how we write down combination? Either we write down this as NCR, where n and c are in the same line, r is subscript. Now NCR in this way, where n is superscript and r is subscript over here, or in this form. Okay, now there is way of calculating NCR without calculator, but you can calculate it using your calculator. So right now we'll observe only this part, means we are working on this thing, 1 plus x to the power 5, where our n is 5. Now possible values can be 0, 1, 2, 3, 4, 5, because your maximum is 5 and there are 6 terms involved. So we can start with 0, 1, 2, 3, 4, 5. So now in your calculator find out the values of 5c0. So if you calculate the 5c0, it 1, 5c1 is 5, 5c2 is 10, 5c3 is also 10, 5c4 is 5 and 5c5 is 1. So now what do you notice about your answers in the expansion of a plus b to the power 5? In this scenario, what we have done is either we can calculate the coefficients. First is either we can calculate the coefficients using the Pascal triangle or combinatorics. Second is the first term, the powers will start from the highest power, that is 5, and it will keep on decreasing. Second term, the power will start from 0 and it will keep on increasing to the maximum power. Okay, so either we can use Pascal triangle over here or combinatorics. And the second is the distribution of power. Okay. Now on the basis of what you have understood, what you have seen over here, now you have to complete the following 4 statements. Take your time, read the questions carefully and figure out. So first question is the coefficient of x to the power 2 in the expansion of this. So x to the power 2 means your second term should have power 2. So 2. Now coefficient of x to the power, now let's verify this part. I need my x to the power 2. So let's suppose you are starting with x to the power 0, x to the power 1 and x to the power 2. So the coefficient in third, this is first term, second term and third term. The coefficient in the third term is 5c2. Let's verify first term, second term, third term. So coefficient over here is 5c2, which is 10, which will give us 10 over here. Okay, now using the same logic, the coefficient of x to the power r in the expansion of this would be, maximum is 5 and you need to calculate the coefficient of r, so this should be r. Now for the coefficient of x to the power 0 means there is no variable involved or independent term, you can say x to the power 1, so it would be 5c1, x to the power 2, 5c2, x to the power 3, 5c3, x to the power 4, 5c4, x to the power 5, 5c5. Okay, now find this is interesting part over here. Find the coefficient of fourth term in the expansion of this. This is fourth term. They are not saying about x to the power 4. They are saying the fourth term. So if you remember fourth term, so if you remember your term always starts from 0, means r starts from 0. So fourth term r would be 3 because if it starts from 0, 0, 1, 2, 3. So fourth term r would be 3. So this should be 5c3. Now let's figure out 5c3 is 10. Now let's go to this part. This is my first, second, third, fourth. Fourth term coefficient is 10, which is 10 over here. Now the coefficient of r plus 1th term in the expansion of 1 plus x to the power 5. So you need to figure out the coefficient of r plus 1th term. So maximum total is 5, so this would be 5. So coefficient of r plus 1 means, let's suppose you need to calculate first your r can be 0, so that would be first term. Now if your r is 1, this would be second term, r is 2, this would be third term, r is 3, this would be fourth term, r is 4, this would be fifth term, r is 5, this would be sixth term. So when r is 0, first term. So first term, so this should be r. Okay? Because in this case, when r is 0, we should get first term. First term means 5c0. Now when r is 1 over here, means you need to find out the coefficient of second term. Second term would be 2c1. Similarly over here, we have calculated the coefficient of fourth term. What we have used is 5c3. Let's suppose if you need to calculate the coefficient of fifth term, it should be 5c4. Now calculate the coefficient of nth term. It should be n minus 1. Now similarly, coefficient of r plus 1th term, it should be minus 1. So it should be r. Okay. Now we have figured out the general formula for the expansion. So let's take the simplest expansion over here, 1 plus x to the power n. So now we know how our binomial coefficients start. Binomial coefficients start from the highest power, that is n. Then we start it from 0. So nc0, nc1, nc2, nc3, and it will go till ncn. First, how many terms would be there in this expansion? In this expansion, there would be n plus 1 number of terms involved. Okay. Now over here the first term is constant over here, second term is variable, and we know the powers of variable second increases. So initially it's x to the power 0 over here, then x to the power 1, x to the power 2, x to the power 3, and it will go till x to the power n. Now using the same logic, we can write it down for any of the binomial expansion. So a plus b to the power n also we can write down in the same way. nc0 coefficients nc1, nc2, nc3, and it will go till ncn. Similarly, first variable a, power is n, it will keep on decreasing by 1, n minus 1, n minus 2, at a point at last it would be 0. Now the second variable over here, b to the power 0, b to the power 1, b to the power 2, and it will go on, keep on increasing, and at the end it would be b to the power n. Okay, now we have understood this expansion part. Let's apply this part, how to solve questions using this. Now the first question is, find in the ascending powers. So read the question carefully always. Find in the ascending powers of x the first 4 terms. So we don't have to write down all the first. In this case, how many terms would be there? 16. In this case, how many terms would be there? 11 terms. So we are not supposed to write down all the terms. So I am solving first. That is 1 plus x to the power 15. So we have to write down just the first 4 terms. So how would we start? First is the coefficient part. So 15 C0, then 15 C1, then 15 C2, and 15 C3. So these are the first 4 terms. First term, second term, third term, fourth term. Now what would be power over here? X to the power 0, x to the power 1, x to the power 2 and x to the power 3. Now simply positive signs are there, so positive over here. Okay, this part is done. Now we can simplify this part and we can solve and get our answers over here. So in this case 15C0 is 1, so value would be 1 in this case. Now 15C1 value would be 15. So in this scenario our value is 15 and x to the power 1 is x, that is value would be x. In this case 15C2 is 105, just check it in calculator, and x to the power 2, and over here 15C3 is 455 and x to the power 3. Done, simple. Okay, now B part. So our question is 2 minus 3x to the power 10. Now if you see, we have seen the expansion for 1 plus x, a plus b, so plus was involved over here. So to make things convenient for us, or to make it easier for us to use this formula, so I would just do a manipulation over here. So what manipulation I will do is, I can write down this as done. Now let's start expanding this part. So 10C0, 10C1, 10C2 and 10C3. Okay, now the first term, which is 2 over here it was 1. Anything raised to the 1 is always 1, so I have not written 1 over here, but this is not 1 over here, this is 2. So we need to write down, because over here the values would change. Now first term gets the maximum power, that is 2 to the power 10, plus second term will get 1 less power, that is 2 to the power 9, and negative 3x to the power 1. And the third term over here, sorry, plus, and let me remove this over here. Okay, now this would be 2 to the power 8 and negative 3x to the power 2, plus this would be 2 to the power 7 negative 3x to the power 3. If you observe, two powers are decreasing, 10, 9, 8, 7. Now powers of negative 3x, 0, 1, 2, 3. So since we have to write down only just the first 4 terms, we have written it over here till here. Okay, but there would be more terms in this. Okay, similarly in this there would be more terms, but they have asked specifically to write down the first 4 terms. Now if you simplify this part using calculator, you will get 1024. Now this would be, if you simplify this part, this would be negative, so negative 15360x, and now again this is negative to the power 2, which is square, so ultimately your answer would be positive. So positive, if you multiply this on calculator, you will get 103680 x to the power 2. Now in this case again negative 414720 x to the power 3, and so on. Okay, I hope you are clear with this idea. Okay, let's move on. Now let's suppose we don't know how to expand this part, means let's suppose if we don't have calculator, but can we solve the combinatorics without calculator? How to solve combinatorics? This is just to give you an idea. So how do we expand NCR, or you can say NCR or NCR? So the expansion of this is, let's suppose if I start with NCR, this is n factorial divided by r factorial, then n minus r factorial. So what does this factorial mean? Okay, notation in the for the factorial mark is the exclamation mark, or we write down this way. In some of the books you will find out in this way, in some of the books it's factorial. So what does 2 factorial means? That you multiply all the numbers, natural numbers involved till 2, means all the numbers involved till 2, 1 into 2. Now 3 factorial means it's 1 into 2 into 3, or the other way around you can write down 3 to 1 or 2 into 1. 4 factorial means 4 into 3 into 2 into 1. 5 factorial means 5 into 4 into 3 into 2 into 1. So this 2 factorial value is 2, 3 factorial value is 6, 4 factorial value is 24, 5 factorial value is 120. Similarly, 6 factorial value is 720, and so on, which can be easily calculated. Just the important thing to note over here is 1 factorial is also 1, okay, and 0 factorial is also 1. This is the most important thing over here to note it down. This we can go and we can check the proof of this when we are doing counting principles. Counting principles, that is in P and C. Now this binomial part is highly related with your probability and stats. If you are taking probability and stats in your A and AS level, or if you are interested in this part, then you need to understand the counting principle theory and the binomials, coefficients and binomial theory. So let's suppose if 5C2, we have already seen the value of 5C2 is 10. So let's check using this logic. So 5C2 over here. So this would be 5 factorial, this would be 2 factorial, and this would be 5 minus 2 factorial, which can be simplified as 5 factorial, 2 factorial, and 3 factorial. Now 5 factorial can be written as 3 factorial into 4 into 5. Now 2 factorial and 3 factorial. So this part gets cancelled. 2 times 1, 2 times 2, 5 times 2 is 10. So this value C. So either you are using with calculators or you are expanding it using this formula. Just this is the thing you should know, means it's good to know, it's not necessary, because you can use calculators and find out the value for any combinatorics. Okay, so I hope this part is clear over here. Okay, let's start solving some questions, because this is the only concept involved over here. Is now we have to see how we can apply this concept in solving the questions. Now in this question, obtain the first 3 terms. First read the question. Obtain the first 3 terms in the expansion of this. Okay, so this is simple. Power is 1, so this would be 2 minus x, simple as it is. Now this part we have to expand. Since we have to obtain only the expansion for first 3 terms, so we are not going to write down all the terms involved in this, because in this expansion there would be 10 terms involved in this. Either or the other way around, you can do it simultaneously, or you can do it other way around. You can first start calculating the value of 1 plus 2x to the power 9. How many terms would be there in this expansion? There would be 10 terms. So let's suppose if I am writing down only just the first 4 terms involved in this. So that would be 9C0 plus 9C1 into 2x plus 9C2 into 2x square plus 9C3 2x cube. Okay, so 9C0 would be 1, 9C1 would be 9, 9 into 2, 18, that is 18x. Now this would be 9C2, 9C2 and into 4, this will give you 144 x square, and one more over here is, that is 9C3 so 9C3 is 84 into 8, that is 672 x to the power 3. Okay, but there would be more in this expansion. We are ignoring that part because our question says we have to write down the first three terms. So we could have taken only the first three terms also in this expansion. Okay. So either you can write down this expansion over here directly, or you can do it individually separately, then write down this part over here. So I'm writing this part over here, 1 plus 18x plus 144 x square plus dot dot dot. Okay, let's change this. Okay, now we know how to simplify this part. First, this 2 would be multiplied with all the terms, then negative x would be multiplied with all the terms. So I can write it down, 2 times of 1 plus 18x plus 144 x to the power 2 plus dot 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 minus x 1 plus 18x plus 144 square plus dot dot dot. Okay, now this part is done. This term by 2 and this term by negative x, and simplify. So over here this would be 2 plus 288. This would be negative x, I can keep this in a bracket, plus this would be negative x x cube. Now just simplify. We have to write down the first three terms, means first term would be coefficient, that is constant term, that is x to the power 0. Then comes is x, so which is positive 35x. Then comes is the coefficient of x square plus 288 minus 80, that is 270 x square. So this is our answer to the given question. Okay, let's move on to the next question. Okay, find the independent term of x in the expansion of this. Okay, first thing is we need to understand this part. Independent of x means we have to find out that term in which we don't have any x involved, means x to the power 0. Okay, now we know that we start distributing powers 9 in such a way that first maximum we give over here, then the second term. So over here, if we want, there are two x involved over here. One is x to the power 1, then there is x to the power 2. So one way of doing it, which I usually share it with my students, is to figure out when the two powers would be same. When the two powers would be same, because when the because one of the x is a numerator and this x to the power 2 is a denominator. So when both the powers would be same, it would cancel out and that particular term would be independent of x. So if I start with this logically, in this your x to the power 9 would be there, and in denominator it would be x to the power 0, because over here this would be 0. Now in this case it would be x8 and this would be power 1. So it would be the same. Now the second case is x to the power 7 and this would be x to the power 2, which would be x to the power 4 over here. Third case, x to the power 6, and in this actually this is 1 upon x square whole square, which gives us this. Over here 1 upon x square whole cube will give us 6. So this and this cancel out, so there would be no term. For which power? 3, means when r is 3. So I can write it down simply, 9c3. Over here the first term is x, which is 9 minus 3, 6. Over here 5 upon x to the power 2 to the power 3. Now once you simplify this part, 9c3 if you calculate on calculator, 9c3, so 9c3 is 84. This is x to the power 6, then this is 5 cube over x to the power 6. So x to the power 6, x to the power 6 cancel out. 5 cube is 125, that is 84 into 125, and when you multiply 84 into 125 you get 10500. So this is the term which is independent of x, means coefficient of that term. And which term is independent of x, we can simply figure out which term. This is my first term, second term, third term, fourth term. When r is 3, term is fourth. When r is 1, term is 2. When r is 3, term is fourth. When r is 1, term is 2. When r is 0, term is 1. We know, we have seen this in our that question logic where 4 questions we have answered. Okay, now look at some more similar questions to this. Okay, now in this question, find in the ascending powers of x. Okay, again the first 3 terms in the expansion of this. Now okay, whenever we have this kind of thing, when there are subparts, so always relate your first part and second part. Okay, let's start with first part first. Now 2 plus x to the power 10. Okay, 2 plus x to the power 10. So expansion would be 10c0, 2 to the power 10 plus 10c1, 2 to the power 9 x plus 10c2, 2 to the power 8 x square, and so on. Now the first part was simple, we can calculate this part. Now this would be 2 to the power 10. So 2 to the power 10 would be 1024. So 1024. Now this would be 10c1. 10c1 is 10. Now 2 to the power 9, that is 512. 2 to the power 9 is into 512x. Now what would be 10c2? 10c2 would be 45, and 2 to the power 8 would be 256 x square dot dot. Now simplify, this would be 1024, this would be 5120x, and this would be 45 into 256, that is 11520 x square. Okay, so first part is done over here. Now find the first 3 terms in the expansion of this. Okay, now let's write it down. 1 plus 2y minus 3y square to the power. Now if you observe carefully over here, these and these are related. How? See, 2, 2, 10, 10, but this is binomial. This is right now not a binomial expression, it's a trinomial. But I can consider this as a binomial. How? If I consider this whole thing as my x. Now this is same as 2 plus x to the power 10. This is same as 2 plus x to the power 10. So wherever I have got x, I will replace that x by this term simply in this expansion, my first part. So I can write down this as 1024 plus 5120. Instead of x, I will write down 2y minus 3y square. Okay, now simply 11520. Instead of x, 2y minus 3y square whole square. Dot, dot, dot. Okay, now just you have to simplify this part. This would be 1024. Now this would be 5120 into 2y. So this would be 102 40y, and this would be 5120 into 3, that is negative 15360y square. Over here, so one more step we will need over here. 11520, this would be 4y square negative 12y cube, and this would be plus 9y to the power 4. Now in the question they have asked us only to expand it for the first three terms, means the constant part 1024, that is y to the power 0, then y to the power 1, which is same 102 y, then we have to expand it for y square. But over here, if you'll see, you will get one y square term over here when we multiply 1150. So 11520 into 4, that would give you and minus 15360. So when you simplify these two terms, you will get plus 30720 y square. Okay, simple. So this is how we can use our binomial expansion concept. When even three terms are there, four terms are there, just club it in the form that ultimately there are two terms to expand. Okay, clear with this idea? Let's move on to the next question. Okay. Now the first four terms in the ascending powers of x in the expansion of this are this. Find the values of this. Okay, so I'll start with this. What I will do is, let's suppose if I write down 1 plus y to the power 7 initially. So my first four terms would be 7c0 plus 7c1 y plus 7c2 y square plus 7c3 y cube plus dot dot dot. Now 7c0 would be 1, this 7c1 would be 7y, now 7c2 would be 7c2 would be 21, so this is 21 y square, and 7c3 would be 35, so this is 35 y cube. Why I started with y? To make things easier for me. Now instead of y, I have considered this as my y, so instead of y I will replace it by this value. So 1 plus 7, instead of y I can write down ax plus bx square plus 21 ax plus bx square whole square plus 35 ax plus bx square whole cube and dot dot dot. Okay, so now simplify 1 plus this would be 7ax, this would be 7b x to the power 2. Over here how many terms are there? Okay, till x cube is there. Now in this part, so either I can write it down below this, so this would be a square x square plus 2 times of ab, so 2ab x to the power 3 and b square x to the power 4. So I will ignore x to the power 4 term over here because we need the expansion till x to the power 3. Okay, similarly for this part I am doing it over here, this cube, so this would be, instead of 35 I'll just write it down, expansion of this a cube, that is a cube x cube plus 3a square b, so 3a square b means 3 plus b x to the power 2, which will give me x to the power 4, I will ignore this term, plus 3 ab square means ax b square x to the power 4, this will give me x to the power 5, I will ignore this part, plus b square x to the power 6, b cube x to the power 6, again I will ignore this part. Okay, so now once we have got our part over here, so this would be 21 a square x square plus 42 ab x cube, over here is plus 35 a cube x cube. Okay, rest of the terms we are not comparing because we have to compare only using this part. Now let's arrange the like terms together. Now this is x to the power 2, x to the power 2. So if you take, this would be 7b plus 21a square. In this scenario, this would be 42ab plus 35a cube is equals to x cube. Okay, now let's compare with this. 1 is 1, so let's start with the first part. Now the coefficient of x in this is coefficient of x over here. Now I will write it down, this expression over here, which is given in the question. So I will use this color over here. 1 minus negative 14x plus 91 x square plus px cube. Now let's compare this part. So coefficient of x over here is 7a, coefficient of x over here is negative 14. So 7a equals to negative 14, which gives me a equals to negative 2. Okay, now let's compare this part. Now 7b plus 21a square equals to 91. Okay, now a is negative 2, we have just got the value, we'll substitute it over here. 7b plus 21 negative 2 square would be 4 is equals to 91. So b equals to 91 minus 84 divided by 7. So 91 minus 84 is 7. 7 divided by 7 is 1. So value of b is 1. Now we need to calculate value of p. So p is equals to this. So p equals to 42ab plus 35a cube. So 42, a is negative 2, b is 1 plus 35, a is negative 2 cube. So this gives us negative 84, negative 35 into 8. 35 into 8 will give us 280. So 280 plus 84 will give us 364. So this is negative 364. Okay, so we got the answers. Values of a is negative 2, b is 1 and p is negative 364. Okay, so I hope you are clear with this idea. Just the main thing that you have to note over here is expansion of your binomial, that is a plus b to the power n starts with nc0, the first term maximum power n, b0, then keep on decreasing the powers of a and increasing the powers of b. And last ncn, a to the power 0, b to the power n. Okay, so I hope you are clear with this idea. Thank you. Hope you enjoyed this session. If you have any doubts, you can put in your comments in the comments box below. Thank you.